by the year 2050, we are expecting there to be 9.1 billion people on Earth. In order to feed all of these people, we are going to need a 50% increase in grain production. So you might be thinking, okay, but why is this a problem? We're going to be able to plant more crops, we'll get more grain, and everything will be great. Unfortunately, it's not quite that simple. Additional land space that is conducive to growing crops is severely limited and won't be enough to make up that difference that we need. So one solution might be to try and identify crops that grow well under non-ideal circumstances. The crop that I work on, sorghum, grows wonderfully under water-limited conditions. So because of this, it is going to be able to grow in areas that corn and other such crops cannot. Sorghum is the 5th most consumed cereal crop worldwide and is specifically used in areas like Asia and Africa. So while this is a great potential opportunity for us, it does not quite get us to that 50%. We're going to need a lot more to get a 50% increase in grain production. The easiest answer for this is going to be to figure out a way to increase the amount of grain that each plant produces. And in order to do this, we're going to have to identify key genes that work to increase grain yields. So the first step in this is going to be identifying how grain yield works genetically. We typically divide traits into 2 categories, quantitative traits and qualitative traits. A qualitative trait is going to be something like eye color. Your eyes are typically brown or green or blue. There's not tons of intermediates, meaning that there's only a couple of genes that affect the color of your eyes. Quantitative traits are not so simple. Let's take height, for example. You aren't just short or tall. There is a huge spectrum of human height. This is because there are tons of genes in your genome that control how tall you are. Height for us is a lot like grain yield for sorghum. There are tons of genes in the sorghum genome that control the amount of grain that is being produced. So far in my project, I have identified 15 key genes that work to increase grain yield. And while this is a great start, it's not enough, and there's so many more genes out there that are yet to be identified. By continuing this search, we're going to be able to change sorghum that looks like this up at the top, kind of like a weed with just a couple of grain on each plant, to sorghum like this at the bottom. Sorghum that produces thousands of grain per panicle and can help us feed the world. Thank you.